So click on the supervised machine learning. Inside supervised machine learning, I have decision tree here. Click on the decision tree, and here is my project 3. So if I click on the project 3, it will be open in our Google Colab environment. So click on it so that it can open on Google Colab environment. So here I am in my project 3. So remember that in project 3, we are going to learn how to implement grid search cross validation with decision tree classifier. Okay, for this project, I need to import NumPy. I need to import tree from Scikit-learn. Then I need to import decision tree classifier from Scikit-learn.tree. I need matplotlib. I need plot tree function, which I will import from Scikit-learn.tree. I need train test split, and I also need pandas. Okay, let's run this cell to import all the necessary libraries. Now, in this project, I am going to use the Titanic train dataset. We have already seen this dataset in the previous sections of the course. So since this dataset is present inside one of our folder, that is, this dataset is present inside the folder of a decision tree, and we know that in order to import the dataset, we need to mount the drive. So in order to save the time, I have already mounted the drive here, and I have already set the path. Okay, now the drive have been mounted, the path have been set. Now it's time to import the data. So I have successfully imported my data Titanic train.csv. This is a CSV form data into my Google Colab environment. Here is the shape of the data. We can see that it has 891 samples and 12 columns. Let's see the head of the data, the top 5 samples of our data. So these are the first 5 samples, and we can see that we have columns: passenger ID, survived, passenger class, name, sex, age, sibling, spouse, parent, and children. This is a ticket, fare, cabin, and embarked. Okay, so out of these all columns, we will use survived as a label. So we have two values inside this column, that is 0 and 1. So if the passenger survived during the Titanic accident, its label will be 1, otherwise its label is 0. Okay, this is passenger ID and this is passenger class. So in that way, we have quite a few numbers of features. Okay, now the important thing is we have to drop the irrelevant feature. So if we see the feature, the passenger ID is one of the irrelevant feature. The other is the name of the passenger, then ticket, and then cable. The information present in that columns, like a passenger ID, the ticket number, the cabin number, or the name of the passenger, does not have any influence on our labels. So that's why they are irrelevant features, and we are going to drop them. Okay, let's run this cell to drop those irrelevant features. And now we are left with these features or these columns. Okay, now check the null values. Check those columns where null values are present. So if I use train is null any, so it will give me the information about the null values which could be present in any of the column. Let's run this cell. So we can see that we have a null value here. The null value is true for the column age, and also the null value is true for the column embarked. Okay, if we see these columns, in age, we have the numerical values. So how we will deal with this column? So basically, this column is different from the embarked. Embarked has categorical values. If I go up and see, there are 3 possible values for embarked: Southampton, Cherbourg, and Queenstown. So here S is Southampton, C is Cherbourg, and definitely there will be Q somewhere because we are only looking at the head here. Okay, so both of these columns are of different nature. It has numerical value, and here we have the categorical value. So we will deal them differently. Here, what I am going to do, I am going to replace the null value inside the column age with the mean value of the column. So what I am going to do, replacing null value in age with the mean value of age. Okay, so I am using fillna. Fillna means filling null values in the column age. Okay, and how to fill? Here I am going to calculate the mean value of the column. So this command or this code will help me to calculate the mean value of the column. And here I am filling the null values with the mean value of the column age, and I want to make it a permanent change. Therefore, in place is equals to true. So let's run this cell and now check the null values again. we can see that now there are no more null values in the column age, but there are still few null values in the embarked. So now it is only one column and it is a categorical column. So we are dropping those rows of a data set where there are null values. So train.drop NA means we are going to drop the null values which are present anywhere in the data set now. And we know that they are only in the column embark now. Let's run this cell and now check the again. So check the null values again. Now we can see that there are no null values present. And now check the head of the data. So we are left with this data. So this data is now clean in terms of the null value. So there are no null values in this data now. Now there is another challenge here. We have two columns, sex and embarks, and they have the categorical values. Sex has two values, male and female, and embarked has three values, that is Southampton, Queenstown, and Cherbourg. Now we have to create the dummy for those categorical. We know how to deal with the categorical features. We create the dummy variables for those features, and then we replace them with the help of dummy variables. So here I am going to create the dummy variable for a column sex, and I am calling it sex. And here I am creating a dummy variable with the help of pandas for the column embark, and I am going to drop the first column of the dummy variable for both the features. So we know that we always drop the first column from the dummy variable in order to avoid the repetition or the multicollinearity. Okay, let's run this cell to create the dummy variables. Now I am going to add the dummy variable to the original data. So here I am using pd.concat, that is pandas.concatenation. This is my data set and these are two dummy variables. Let's run this cell to concatenate these along the columns of our data set. So we can see that the embarked, male, male, Q, and S, these are the three new columns in our data set. And these three columns are the dummy variable for the column sex and embarked. So in this way, the dummy variable has been created and they have also concatenate or join with the original data set. Since the dummy variables for sex and embarked column has been created, now it's time to drop them. So here we are removing sex and embarked because their dummy variables are created. So the command is train.drop. These are the two columns which we are going to drop. So they are the column. That's why axis is equals to 1. In place is equals to true means we are going to replace them permanently. Okay, let's run this cell. And now we can see that this is our final form of the data before extracting the feature or the labels. Since the data is clean, all the challenges have been addressed. Now it's time to extract the feature and the label from the data set. So the features are all the column except the survived column. So that survived column will be used as our label in the data set. So the command is train.drop. We're going to drop this survived column only. So if I drop survived and retain the rest of the column, I will be able to get the features. And if I only take the values from the survived column, I will get the label. So here in this way, I have extracted the feature matrix and I have extracted label from my data set. Now it's time to perform a train test split. Here I am using X and Y as an input, and I am going to use 20% of my data as a testing and remaining 80% as a training. Okay, let's run this cell to perform the train test split. Now it's time to apply a decision tree classifier. Okay, here I am going to apply a decision tree classifier with all the default value. If you see here, I am not going to pass any input parameter, and I am going to fit this decision tree classifier directly to my training data. Directly mean that I am going to use all the default values. Okay, let's run this cell. Now it's time to get the predictions. So for get the prediction from the trained classifier, I need to pass the testing component to my classifier. Here I am passing the testing component and I am getting the predictions. Let's run this cell. Now it's time to calculate the accuracy. For accuracy, I will compare the prediction of a model with the label of a testing component. Then I will calculate the mean and multiply with 100 if I want to see the accuracy in percentage. Let's see the accuracy in percentage. So it is 75.28. So the accuracy seems to be less. And there is a margin of improvement here. Like it is only 75%. But we have a large data set. It means that now there is a chance that our tree has entered into an overfit condition or overfit region. We have to construct the tree and see whether it has entered into the overfitting or not, because the value of accuracy is very less. So there is highly likely that our tree has overfit. Okay, we will see with the construction. Let's create the confusion metric first. So this is very standard stuff. Here we are only going to see the confusion matrix. So let's run this cell, import the confusion matrix, and see the confusion matrix. So if we see the confusion matrix here, there are large number of samples which are misclassified. If you see, this is 28 and this is 16. So there is still a margin of improvement. Okay, let's see first, before improving, let's see first how tree looks like for this particular data set. Okay, let's plot the tree. So we have clicked on this cell and we are waiting for a tree. Now it is still running. I think the maximum depth of this tree is very large. That's why it is overfitting and we are getting a less accuracy. If we see, it is still running, it is taking time in order to plot the decision tree. So maybe its depth is more than 10 or 15. Look at this tree now. Now look at this tree. This tree is very large in depth. If you see here, the depth of the tree is very large. Okay, before getting into the tree, let's see what is the most important feature of this data set for the tree. We know that that feature is most important, which has the high information gain, and that feature become the root node of the tree. Okay, let's run this cell. We have already seen this line of code in our two previous projects. So this is the command, that is decision tree dot feature importance. And here we are just transforming it into the data frame. Okay, if you see here, the age column has high information gain 0.26, and the most value is with the male. So it means the male is the most important feature, and our decision tree will be starting from this important feature male. Let's see our decision tree. So in order to see this decision tree, let's click here. So its size has increased. If you see here, if I move this bar here, center, so that I can see the tree, let's scroll up and see if we can reach to the top of the tree. So you can see how large is this tree. Okay, scroll this further. And so I think we have to move it to the left side now. Okay, something here. And if I scroll it up so that I can see the top feature. Okay, if you see here, this is our top feature. Now you can see that it starts from the male. If you see the male, its Gini is 0.472. So we have confirmed that our tree has started from a feature male, which is the most important feature, and we have confirmed with the information gain value of the tree. So this is our tree, and this is the most important feature. It starts from male. If you see, it has very large depth. So it has entered into the overfitting condition. Now, how to avoid overfitting? We have learned in the theory of a decision tree, that is, we need pruning in order to avoid the overfitting. So here we are using pre-pruning, because we know that there are two kinds of pruning, pre and post. So here we are going to apply pre-pruning in order to increase the performance of a decision tree by stopping it to enter into an overfit region. That is, by avoiding it for overfit condition. So this is the overfit tree. You have seen the length of the tree. This is called the overfit tree. Now we have to set the parameters so that we can prune our tree and get the improved performance. If I scroll up and see the accuracy, so the accuracy is 75.28%. Let's see whether we are able to improve it or not using the grid search or using the pruning. So the pruning can be performed using a grid search method. This is the best way to perform the pruning, because in pruning, or especially in pre-pruning, you have to set the parameters. So setting up parameters using a grid search method is the best idea. So what are the parameters which we are going to set here? Okay, So first I am importing k-fold from Scikit-learn.model selection. Then from Scikit-learn.model selection, we are also importing grid search cross validation. Okay, let's run this cell. Okay, so I am going to see the maximum depth, the minimum sample leaf, and the criteria. So these are the important parameters for a decision tree, and we can also check here by calling a help function on a decision tree classifier. So this is our help function. It has a lot of parameters that can be input to the decision tree classifier function, but the important is the criteria here and the minimum sample leaf, that is how many samples should be in the leaf node. The definition of minimum sample leaf is that how many samples should be in the minimum, how many minimum samples should be in the leaf or the terminal node. And the other is maximum depth. Here the maximum depth by default is none. That's why it allow the tree to grow to the infinite depth. That's why it has entered into the overfit condition. So we are going to use these important criteria, these important parameters, that is the criteria, the maximum depth, and minimum sample leaf. Okay, so what I am going to do here is for maximum depth, I am providing the values between 1 and 12. This is quite a large range because we have a large data set, we have a challenging data set. Okay, for minimum sample leaf, we have value 1, 2, 3, 4, and 5. And there are only two possible values for the criteria. So I am passing Gini and entropy. So these are the parameters which I am going to give to my decision tree classifier. These are the possible combinations of my parameters. And this model, the decision tree classifier, will select the best value for these parameters so that we can avoid overfitting and we can improve the performance of our decision tree. Okay, so this is very standard stuff for the grid search. So we are using 5-fold validation. Okay, here I am instantiating my decision tree. I am calling it decision tree grid search. Here I am fitting, or I am calling the grid search cross validation function. This is my model here. And these are my parameters, and I am using CV is equals to CV, which is calculated from here for 5-fold validation. Here I am going to fit my cross-validated model to the training component, and here I am getting the best parameters. Okay, let's run this cell to observe the best parameter. Let's see how long will it take. Okay, so it is taking a very few seconds. Okay, so the criteria it has selected is a Gini. Okay, so the maximum depth has been selected as a 11. So out of this 12, the maximum length has been selected as 11, and minimum samples that should be present in a leaf or terminal node should be 5. So these are the parameters which has been selected by a grid search method by our decision tree classifier. Okay, let's get the model from this best parameter. So this is our best estimator model. Here we are getting the prediction from our best model. And let's compare the prediction of a model with the original label of a testing data and see the accuracy now. So we can see that our accuracy has improved. Okay, so our accuracy has improved. If I scroll up, the previous value of accuracy was 75.28. And now my accuracy is 78.09. So we can see that we have improved the performance of our decision tree classifier by setting the parameters, by doing the pre-pruning so that it should not enter into the overfit region. Okay, now it's time to plot the tree again. It is plotting the tree with the maximum depth of 11. Let's see how our tree looks like now after the pre-pruning. Definitely its size will be reduced. So you can see that its size has been reduced. If you see, there is a balance here and its depth is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. You see, it has 11 depth now. 1, 2, here 11. If you count after the root node, its depth is 11. And 11 is the depth which we have calculated using a grid search method. So this tree is not entering into overfitting. Its performance has increased. Now see this tree with this tree now. So you can see its depth is very high. Like if you count 1, 2, like from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it's still going on 16, 17, 18, 19, 20. So the depth of this tree is 20. That's why it has entered into the overfit region and its accuracy was low, that is 75%. But when we do pruning with that tree, we obtain the maximum depth of 11 here. So from 20, we reduce the depth of a tree to 11, almost half. That's why our accuracy has improved and we have avoided overfitting. So the last thing is, with this new tree, let's check the most important feature now, whether it has changed or not. Let's run this cell. So we can see that the most important feature still is a male feature. And now its information gain is 0.43. Here, this is a male feature. So in this project, we learn how to perform grid search cross-validation using a decision tree classifier. The other thing which we learn is that how to perform a pruning, especially the pre-pruning, in order to improve the performance of a decision tree classifier. We also learn how to set the parameter with the decision tree classifier and how to get the best value of those parameters in order to avoid the overfitting. So I hope you understood this project very well. Thanks for listening, and I will see you in the next lecture.